recording. What a deal. Okay. Let's try this. That's not quite what I wanted. Don't do that. What a way to start out, right? Anyhow. So I want to take care of this one first here. We want to simplify this by rewriting each trig function. Okay. So you've got cotangent theta over cosecant theta. Now this is one of those situations where you're better off trying to get it into a sine and cosine type of a deal. So the question really boils down to is what are these things equal to in terms of sine and cosine? So cotangent is going to be equal to what? Okay. So we end up with cosine over sine, and we know that we're dealing with theta, so I just generally forget about that stuff. And what does cosecant give us? What's cosecant? 1 over sine? 1 over sine. So, now that I've got those rewritten in terms of sine and cosine, we're just simply going to multiply by its reciprocal, so you'll end up doing sine over 1. Sines cancel, so this really just turns out to be cosine of theta. All it is. It's just simply going through and manipulating things out so that you can rewrite them in different terms. Okay. So, if I try B here, we're supposed to show that this is equal to that by multiplying in the numerator by the sine of 1 minus sine theta. Okay. So, get cosine over 1 plus sine theta is equal to cosine that goes up there, then 1 minus sine theta. So, if I were to go and multiply, because it says multiply the numerator and denominator by this, well, 1 plus sine and 1 plus sine over here, that works, right? Over here it would be 1 plus sine and 1 plus sine again. Now, if I take a look at this bit over here, this is going to end up giving me 1 plus sine multiplied by cosine theta. But down below here, what is this going to be? Oh, hold it. Did I write that down correctly? Oh, that was supposed to be pluses. That's plus, that's minus. Sorry. That's my bad. You just wanted to let me keep going with it until I figured out I made a mistake, huh? Yeah. Just make me feel better. Okay. But down here, when we take a look at this is going to turn into be a difference of 2 squares. So we end up with 1 minus sine squared. Okay. Now, the thing is, when it said, did it say by multiplying the numerator? Yeah. We could do this to both sides, but I'm just going to leave this alone over here for the time being. I'll show you why here in a second now that I've actually done this in my head. What is 1 minus sine squared equal to? Well, if you go back and you've got your sine squared plus cosine squared is equal to 1, if I were to go and put this over here, I would get cosine squared is equal to 1 minus sine squared. So you might want to go through and manipulate that in your notes so that you can have what cosine is equal to, what sine is equal to, because now I can rewrite this as 1 minus sine multiplied by cosine theta over cosine squared theta. Well, can I get one of these cosines, take care of this up here? So that goes off, this goes here, so I have 1 minus sine theta over cosine of theta is equal to, but wasn't that what they wanted us to figure out what it was? Right there. So you can go through and do simplifications like that. Sort of kind of makes sense? Just looks kind of odd working with things like that, but again, that's what those wonderful little identities are for. They help out immensely on that. So, let's see. They want us to simplify this by writing the expression over a common denominator. Well, if I was going to try and get a common denominator out of this, what would I have to multiply through by? Well, would I take the first one and multiply it by cosine u over cosine u? That would end up being 1 plus sine u over sine u. Plus, and then here we've got cotangent u minus cosine u. This here already has cosine down here, so I would multiply this one here by sine u over sine u. I know, it looks like a confounded mess, doesn't it? But that does set us all up so that we end up having, let's see, cosine u plus cosine u sine u and then we're going to end up with plus cotangent u sine u minus cosine u sine u all over, bring that down a little bit more, all over cosine u sine u. Does it look like a mess? But I've got plus cosine u sine u here minus cosine u sine u over here. Those two just wipe each other out, didn't they? So now I'm left with cosine of u plus cotangent u sine u over cosine u sine u. By the way, what was cotangent equal to? Cosine over sine. So if this is really cosine over sine here, that would cancel with that, wouldn't it? So you're left with cosine u plus cosine u all over cosine u sine u. Now, are cosine and sine the same? Are cosine u and cosine u the same things? So that's really the same as saying I have 2 cosine u over cosine u sine u. So, boom, boom, those two just disappeared, and you're left with 2 over sine u. Huh? Again, all it is just simply the mental gymnastics of plugging it in, seeing what it's equal to. All of the algebra works just like it had before. Nothing is new there. Okay? It's just working through it and learning how to manipulate things with sine and cosine. Okay. So, want us to simplify by factoring. Okay. So I got sine squared minus 1. Now, you have to recognize, being a polynomial, that this is a difference of two squares, isn't it? Because you got something squared here and 1 is squared, so I could rewrite the numerator as sine v minus 1 multiplied by the sine v plus 1. That's factored out the top, right? Could I then go through and factor out a tangent v? So if I take tangent to v, what's left? Well, that's going to be sine v minus 1. Boom. So that cancels with that, and I am left with the sine of v plus 1 over tangent of v. Now, granted, tangent is equal to sine over cosine, and you could go through and multiply that together, put that up over on top. You'd be able to wipe it out here, but you'd actually do this over here and make it a more complicated expression. Okay? So I would technically stop right about there. Let's see, did the book go any further with that? No, book left it right there as well. Okay? But that's what it is. You guys don't look so enthused. Okay. Let's see if there's anything else on here that I should. Now, when they say establishing the identities, all they're really doing is just having you go through and prove that that is exactly what they are. So I'm not really going to take the time to go through and do that, because that's all that they really did, is just went through and established the identities, demonstrating why they are what they are. So that's that. I'm going to let you guys get through it.